Hello everyone, I hope you're having a good day watching Fyne Conference 2022. I am going to be talking today about cross-compiling in the cloud with Kubernetes and how that is going to help you build for all Fyne on every cross platform that Fyne support. So the plan I'm going to be following today will be a short introduction of who am I. Then I will be covering a little bit about cross-compilation and fyne-cross, which is a tool that enables that with Fyne. A little bit of what are the difficulty of working with all of these different platforms, even with that infrastructure, and how using a Kubernetes cluster can help you for solving some of these problems. And I will also cover why FyneLabs did develop and work on fyne-cross to actually develop its own service that make it even easier. And I will come back to fyne-cross and talk about the futures and where we are putting effort for improving it. So quickly, who am I? I'm Cedric. You can contact me at cedric@fynelabs.com. Don't hesitate if you have any question later on to reach out. I am the current CTO at FyneLabs. We've been trying to create products that enable development of Fyne application more easily and more productive for the entire ecosystem. I have been a software developer for a long time now, doing C and C++ for most of my career, and I have been doing Go only lately. So the problem we're going to be covering in this video today is about the fact that each developer has mostly one computer to develop on, but all of these users are running on so many different OS and architecture. If you think about it, you have people running Android, BSD, macOS, Linux, Windows, and they have like x86 or ARM or even ARM64. So all of these variations give a really big matrix of platform you need to support. And for all of this platform, the solution, if you have only one computer, is to set up what is called a cross-compiler. And so Go does provide already cross-compilation for all of these OSs and platform OS and architecture together. But as we depend on some C library, or in the case of Fyne, we depend on glfw, we actually need to have a C cross-compiler. And that doesn't actually mean that we need to have one compiler for each couple of OS and architecture. And that does really increase the complexity of setup and maintenance of all of these components across the board. So for that, it would be great if we had containers that were providing the tools already necessary and just for each platform, maintained for us and working just out of the box. And even better if instead of running manual things inside a container, if we actually had a tool that was piloting this container to do the build for us so that we don't even have to care about all of this setup. And that's exactly what fyne-cross is. And that's really a really great cool tool that was created by Luca. Really thanks a lot for that. It's enabling basically everything I described before to actually be done automatically and magically for you. It will pull actually a container for each OS CPU combo you want with everything you need in it. It's kept up to date with latest Go, latest Fyne. You just need to have a Docker or Podman running locally, and everything else will be just magically done for you. So as a tool, it's really enabling you to build all your application with basically as little setup as you can imagine and as little maintenance as you can think of for all the platform that Fyne supports. So it's really the way to build for so many platforms at the same time. And it's pretty straightforward. You just type fyne-cross and the platform that you want to actually target inside the product that you want to build, and we'll just prepare the container, run go and find and do the packaging for you into the container, and at the end give you a package result, and you just have to use that. And it's really straightforward. It has a ton of options, so you can all like customize things very thinly, but the default out of the box is just work. And so that's really, really helpful. It still has a little bit of drawback, obviously, because you still need to have a lot of storage, because now for each platform, instead of just having a container, you still have to have like a container with an OS and all the tool in it, and they can be really big. For example, Android, I think it's like 10 gigabytes for Android alone, and we have like 5 or 6 different OS and combo there. So it does require a lot of storage on your dev machine if you want to test to build on all of this platform. Obviously, building takes time on all of these platforms. Even if fyne-cross does use Go cache, it's still going to take quite a lot of time to get there. So most people will actually use this tool on GitHub Action so that they don't have to put that into their pipeline. It does consume a lot, obviously, of GitHub Action if you have a private repository. So there is some limit there on what you can actually, not limit, it's just increased cost. So that's where Kubernetes come into play, and that's where Kubernetes cluster actually is helping. A lot of companies have Kubernetes cluster already, or you can set up one pretty easily and straightforward these days. You can have one in the cloud or on-premise. It really depends of what kind of hardware you have and what's your hosting setup are. But once it's done, you can really use it to offload all your cross compilation to it, and you can do that by using. You can do that either from your developer workstation or from a GitHub or a join deploy command. So it does help to have a Kubernetes cluster to do as much build you want, and you can do that, all of that in parallel. So it does really, Kubernetes is going to be enabling you to do a lot of this build from much cheaper, and to enable your developer to actually be able to do that directly without the need necessarily to go via your GitHub or join deploy actions, so that they can basically do a small iteration locally, say, is that going to work? Do spin, get the tables they want, and check that with the user or the customer that are actually playing with that application. And so that's why we did at FyneLab work on the Kubernetes support for fyne-cross. It's still in PR. There is still a little bit of discussion on how to integrate the Kubernetes part, especially the module that it depends on, which have a lot of dependency, quite complex for just accessing the Kubernetes API. So there is quite a few ways we are still discussing, but it might come shortly. The code that it's based on has refactored already all of the code base of fyne-cross to make it easier to add your own engine. So I will cover at the end how you can actually implement another engine. I am not too sure of how useful that will be, because after Docker, Podman, and Kubernetes, I'm not too sure of what would be the next one to implement. But who knows? It's easier, so we'll show it. So the Kubernetes fyne-cross code will take care of creating pod into your cluster, control the build inside the pod, and retrieve the result of that build and destroy the pod. We use a temporary S3 storage to be able to push content to the Kubernetes cluster and download it into the cluster, because there is not really any other protocol to go by here. There is a lot of open source implementation and alternate services, so you don't really depend on Amazon for having a S3 storage. And from there, you can actually run the same fyne-cross, but with the Kubernetes engine from your GitHub action or drone deploy, which make your life quite easier, and you can actually leverage that simplification. Also, from your desktop developer station, you can actually just type fyne-cross, like in this example, fyne-cross Linux -engine Kubernetes, and it will actually upload the project that you are building locally into S3. Then it will download it into the cluster pod, and it will also do automatically the caching of the build for you. It then does exactly the same thing that the fyne-cross locally was doing, do the building of the binary, package the app, or generate the tar.exe, and will actually download it back on your local machine. And that's basically as easy as it gets. We do have a lot of command line argument that you can actually use to specify your S3 storage, your Kubernetes namespace, and things like that. It's something we could actually put maybe into environment variable or into a file, config file. At the moment, we haven't really done anything like that because we don't really have a use case, but if you have any suggestion, just reach out. That would be interesting to add. But that is still quite a lot of work to set that up, and actually we can make it better. And that's the reason why our FyneLab is using fyne-cross. We have been trying to build a build system to deliver apps across all the platforms and the OS you want to support, and that's it. Here you go. So we support private and public repository, and as you can see, you have webhook, and so that every time you tag a build, it will be triggering the system, and you get to have nothing to do there. And the deploy key is used for private repository, so that we can access all things there. And once it's done, you get all your binary that you can now test on all the devices, and you can exchange that, and once you publish with your users to make sure that everything is of quality. And we are working there to go towards the idea that we should be able to deliver these apps all the way to the user. And so currently we are working on adding self-update support. We have already open sourced earlier this year self-update software, and we are using this solution to build our own infrastructure there. And so it will take care for you of when you push the publish button to make things happen into a CDN that your application can pull instantly and will be able to get their update from. We'll be working later on adding application store delivery or hosted portal, depending on what our customer kind of demand and prioritize. And the idea being that if people are more interested to reach to large customer base, application store is the way to go. But if it's more for people inside a company, hosted portal may be what they are looking for. So this is more of a product that will come later on. We'll see where we head there. But let's go back to fyne-cross. And so we did a lot of work on the refactoring of the engine interface. And so as you can see now we have the container engine, which is in charge of creating the container image for a specific architecture and OS. We can also specify the container image we want to use for that couple. And the idea is that if you do have some C or binary thing that are not in Go but in other language, you can actually package them into your own container and be able to still use fyne-cross to orchestrate things on top. So this is a way if you do have dependencies that are not in Go. And once you have created a container image, there is a few steps that will be taken care of by fyne-cross. fyne-cross will call you to prepare that container to be receiving order. I will cover just after what does that mean. And then fyne-cross will run command in it that it wants to be able to do. So it expects Fyne, Go, and a few commands inside the container, so that it does actually it can build things inside the container. And when it's done, it will call finalize, which is expecting to be extracting that resulting package out of the container to transfer it locally and destroy the container after that. And so the preparation of the container image is when we actually are indicating to the engine which mount point locally we want to expose into the container, which environment variable we want, things like that. So in the case of Kubernetes, the mount point cannot be exposed directly from locally to the cluster. So we are actually uploading them to S3 storage and then downloading them back into the container. So that's what we are setting that up there. We need to have still storage into the container to receive this data, because the container in Kubernetes is read-only. So we have to set up a few mount points that have like a certain storage capability. And the second point is that environment variable in the case of Kubernetes are set once when you set the pod, and you cannot really easily override them otherwise. So the easiest thing to do there was to just set all the environment variable when we set up the container, and that's why we do that in this snippet. And with that, we're getting toward the end of a talk, and I want to talk a little bit about fyne-cross future. So obviously, fyne-cross is a community effort. It has been led by Luca to get where it is today, and it has really a lot of good ideas to move forward. One of the problems we have today is that we cannot provide a downwind image because of Apple license on their tool, and so all the users of fyne-cross are forced to manually download and compile themselves the downwind image so they can actually use it. This is not ideal, and there seems to be some interesting solution around Zig as an alternative C cross compiler that seems also to be able, like Go, to compile for a much larger number of targets. So we might be able also to reduce the amount of container we have, which will reduce the burden on the developer on the storage of what he needs there. So that would be a really nice improvement. But what will be really nice is fyne-cross is really useful to everyone, and it's really the way forward, I think, for setting up your environment, for compiling for any other platform than the one you're on. And that makes kind of a logical sense that we actually include that as part of Fyne and make that really something that Fyne does right away. So one of the plan this roadmap is to actually make it possible for Fyne to pick up fyne-cross capability. So for that purpose, we will refactor a little bit more of the code into fyne-cross so that the command line argument module match Fyne, and then we should be able to move fyne-cross code into Fyne command line and be able to have a new fyne-cross command line. And at that point, it will be really nice if we can automatically detect and magically decide when the OS we're running on doesn't have a cross-compiler setup or is missing something, and we should be able to say, oh, well, let's actually switch to fyne-cross, download this image, and off we go. We are now able to support that platform without having the user having to install and maintain all of this for us, making basically Fyne as a tool able to support all the platform that Fyne the toolkit is actually able to support. And I think that's where we really will be aiming for, is to this great tool should be part of the core of Fyne, as this really enables a lot. And so that's how I will be concluding my talk for today. Don't hesitate to reach out on Slack or Discord if you're not able to attend later on the Q&A. I will be there to also answer your question. So on Slack I'm Cedric, on Discord I'm Bluebugs. And you can also reach out via email. And yeah, do not hesitate.